Hi, and welcome to section 1.2, Data, Sampling, and Variation in Data and Sampling. We're going to be going over quite a few topics today, so let's get started. Maybe I can click. There we go. We're going to first talk about data types. Data can come from a population or from a sample, and we usually use small lowercase letters, X and Y, to represent data values. Most data that you're going to work with can be put in one of the two following categories, either qualitative data or quantitative data. Qualitative data is a result of categorizing or describing the attributes of a population. Usually it's like hair color, blood type, ethnic group. Those are all examples of qualitative data or ways of categorizing people or other data subjects. Quantitative data is always numbers. So it could be the result of counting or measuring an attribute of a population. It might be the amount of money in your bank account, your pulse rate, your weight, and within quantitative data, you can either have discrete values or continuous values. Discrete data are going to be the result of counting, and they take on only a certain set of numerical values. For example, if you count the number of phone calls you receive every day, you might get values such as 0, 1, 2, or 3. Those are discrete values. Continuous data are the results of measuring. And when you continuous data assumes that we can measure really accurately. So for example, let's say we measure how much everyone's backpack weighs with books in them. Well, if we could measure to any level of accuracy, we could say that the weights are continuous because you could have any value. You could have 5 pounds, 2.657 ounces. You could have 10 pounds, you could have 7.3 pounds, right? There's any value in there that could be possible. So we think of that as continuous data. So let's go through an example and see if we can practice deciding if data is quantitative discrete, quantitative continuous, or qualitative. So let's say we go to the supermarket, we purchase 3 cans of soup, tomato bisque, 1 can of lentil, 1 can of Italian wedding, a couple bags of walnuts and peanuts, some vegetables, and 2 containers of ice cream. So what I would like you to do now is pause this video and think of a data set that would give me results that are quantitative discrete, a data set that would give me results that are data that is quantitative continuous, and a data set that would give me results that are qualitative. And there's a lot of different answers. So just go ahead and sit down and see if you can figure out data that would fall into each of those 3 categories. All right, are you back? Great. Let's go and look at one example. You could have a different one. One example of quantitative discrete would be the numbers of items you bought. 3 cans of type soup, 2 cans packages nuts, 4 packages vegetables, 2 packages desserts. Those are all discrete because we have nice whole numbers, and they're data because they're numbers. Quantitative continuous, maybe the one I thought of was the weights of the soup. 19 ounces, 14.1 ounces, 19 ounces. Really, the soup could weigh anything possible, any number of ounces. And the one I thought about qualitative was just like the categories of things I bought, maybe types of soup. Well, I got 1 Italian wedding, 1 tomato, and 1 whatever it was. Maybe the types of vegetables. Those are things that would be categories. All right, so here's another example of practicing getting the correct data type, quantitative or qualitative. And once you figure that out, decide if the quantitative ones are continuous or discrete. Go ahead and pause the video and go through these and see if you can decide which are which types. All right, are you back? Let's go through these. The number of pairs of shoes you own, that's going to be a number. So we know that that is quantitative. And it's going to be a whole number that you count. So that's going to be discrete. So quantitative, discrete. The type of car you drive, that's going to be qualitative data. The distance it is from your home to the nearest grocery store, well, that's going to be a number. So it's quantitative. And it could be really any number depending on your accuracy of measurement. So quantitative, continuous. The number of classes you take a school year, quantitative, discrete. Again, you're going to count those. The type of calculator you use, that's going to be like Casio or TI, so that's qualitative. The weights of sumo wrestlers, that's going to be a number, so quantitative and again, continuous. Number of correct answers on a quiz, quantitative, discrete. And IQ scores, well, that's going to be quantitative and also discrete. I think you can only get whole numbers up to a certain point for that one. So here are my answers again to check those. I went through those a little bit quickly. All right, so let's start talking about pie charts and bar graphs. And here's a little video for you to watch, very short.
This is a pie chart describing my favorite bars. And this is a bar graph describing my favorite pies.
I just like that. Just a little break in the video. All right, let's start talking about pie charts and bar graphs. So went too far. Hang on. Ah. So tables are a good way of organizing and displaying data, but graphs are more helpful for understanding the data. And there are not strict rules about which graphs you should use, but two that we're going to talk about now that are used to display qualitative data are pie charts and bar graphs. So we have some data here. It's in a chart, and you can go through and clearly read the different information about full-time, part-time students. But if we put it into a pie chart, it's a little bit easier to see that Foothill College has more part-time students than De Anza College. So each chart, each pie has the number of degrees as the percentage of the population. So this has a larger degree area than this one because it's 59.1% of the population, and this is only 40.9%. Again, the same for this one. This is 71.4% of 360 degrees, and this would be 28.6% of 360 degrees. We label each category. I'm sure you've seen these before. Sometimes pie charts aren't so great to use if the data, in fact, can add up to more than 100%, and that happens when a student could be in more than one category. For example, a full-time student could be under the age of 25. So those are going to be repeated categories, and we have more than 100%. So for those, we can use a bar graph, right? A bar graph is used to compare the relative size of these categories. A pie chart could not be used because they add to more than 100%, and sometimes they add to less than 100%. So that's also when you can't use a pie chart. Here's another pie chart. When the percentages don't add up to 100%, what you can do is you can put in like other. That helps to fill in some gap if you don't have all the information. This one looks a little bit nicer. I think chart B here looks a little bit nicer because they went from largest to smallest wedge. It's a little bit easier to read. So that's another example that we do. Bar graphs can be organized that way as well, from largest to smallest. When we do that, we call it a Pareto chart. So here's an example of a Pareto chart where it goes from largest to smallest. It just makes it a little bit easier to use.